Bismillah ar-Rahman Rahim. In this session, we will discuss topic stars and universe from IGCSE and O level physics. And here we have uh, question number one. Name the type of the radiation emitted by the sun. The sun is a medium star which consists mainly of hydrogen and helium. Helium and hydrogen. Mainly, the sun contains hydrogen and helium, and that the radiant energy it emits is mostly in the infrared, visible, and ultraviolet region of the electromagnetic spectrum. This radiation is emitted from glowing hydrogen, which is heated by the energy released in nuclear reaction within the sun. A nuclear reaction or nuclear fusions occurs in the sun mainly due to fusion of hydrogen, which produces helium, and a huge amount of energy release, and it emits radiant energy. This huge energy in the form of light, infrared, visible, and ultraviolet region of light. So this is the type of radiation that emits from the sun. How are stable stars powered? Stars are powered by nuclear reaction, or that is a fusion reaction. The stable stars such as our sun are hot and dense enough in their center for nuclear fusion of hydrogen into helium to occur. The high temperature in the core required to sustain the nuclear reaction is maintained by a large amount of energy released in the fusion process. In the fusion process of hydrogen to helium, it requires a huge amount of energy to sustain the reaction. So as a result of that huge energy, the more fusion reactions occur and more lights are or more energy is released. The sun is powered by the nuclear fusion. Some of the energy generated in the core is transferred to the outer layer of the stars, and some of the energy which is produced in the sun is released or is transferred to the outer layer of the stars. These are cooler as compared to the center core and less dense than the core, but are still hot enough for the hydrogen gas to glow and emit electromagnetic radiations into space. Stars vary in age, size, mass, surface temperature, color, and brightness. The color and brightness of stars both depends on the surface temperature, which in turn increases with the mass of the star. Stars that are white or blue are hotter and brighter. White and blue are hotter and brighter, surface temperature of 6,000 to 25,000 Celsius, than those that are red or yellow, surface temperature is 3,000 to 600 Celsius. Now stars. Sun is our closest star and is so bright that it banishes the darkness of space with its light. So is the closest star and it banishes, so bright that it banishes the darkness of space with its light. When the sun sets due to the rotation of the earth, the night sky is revealed away from the light produced by the human. The night sky presents a magnificent sight with the millions of visible stars. Although the stars may seem close on a dark night, in fact the distance involved are enormous compared with the distance across our solar system. So great that we need a new unit of time, length of time, that is light year. This is the distance traveled in vacuum of space by light in 1 year. So they are so far away that the new unit of length is light year. Light year is the distance. This is the distance traveled in vacuum of space by light in 1 year. So the star nearest to the solar system is Alpha Centauri, 4.31 light years away, which means that light arriving from it at the earth today left 4.3 years ago. So 4.3 years ago light reaches to the earth after 4.3 years. So the pole star is 142 light years from the Earth. The pole star is 142 light years from Earth. The whole of the night sky we see is the past history. The whole of the night sky we see is the past history, and we will have to wait a long time to find out what is happening there right now. So we cannot see it because in our lifetime, which is 142 light years, we cannot see all these things. What is happening today can never be seen, and a typical human cannot see it. A light year, the 1 light year is the distance traveled in vacuum space by light in 1 year. So light in 1 year in a vacuum space is the 1 light year. That is nearly the distance of 10 million kilometers. So 1 light year is equal to 9.5 into 10 raised to power 12 kilometer. 9.5 into 10 raised to power 15 meters. So this 1 light year is this meter. A galaxy is a large collection of stars. There are billions of stars in a galaxy. As well as containing stars, galaxies consist of clouds of gases, mostly hydrogen and dust. They move in space, many rotating as a spiral disk like huge Catherine wheels with a dense central bulge. So galaxies, there are many galaxies. So the Milky Way, the spiral galaxy, to our solar system belongs. Our solar system belongs to a Milky Way, can be seen on a dark night as a narrow band of light spread across the sky. So our solar system belongs to a Milky Way galaxy. So test yourself, page 289 from the Heather Kennett book, written by Heather Kennett and Tom Duncan, and published by Hodders Education. So this book is very, very important. The universe is composed of stars and galaxies. Which of the following statements are not true? The universe is a collection of galaxies. Yes, true. There are billions of stars in a galaxy. Also true. Sun is a star. True. Our solar system belongs to a Andromeda galaxy. No, our solar system belongs to a Milky Way galaxy. Milky Way, not Andromeda, but belongs to a Milky Way galaxy. So now question number 4. How long does it take light to reach to the Earth from a galaxy 10 million light years distance from the Earth? Choose your answer from the following option. So 10 million years ago. Test yourself, page 291. When a light mass red giant has consumed most of the helium in its core, it may turn into a white dwarf. When a low mass radiant consumes most of the helium, so in its core, it may turn into a white dwarf. When a high mass red giant, it's a low mass red giant. When a high mass red giant consume most of the helium in its core, it may become a neutron star. We will see the cycle, the Big Bang theory. If the galaxies are receding from each other, it follows that in the past they must have been closer together. It is therefore possible that initially all the matters in the universe were packed together in an extremely dense state. The Big Bang theory proposes that this was the case, that the universe started about a billion years ago from one place with a huge explosion. That is a Big Bang. So the Big Bang theory, according to the Big Bang theory, the universe exploded or extended and even extending today. The resulting expansion of the universe continues to get today, but predictions vary about what will happen in the future. The critical factor appearing to be the density of matter in the universe. There is difficult to calculate because the scientists currently believe that such as 80% of the material in the universe is invisible since it does not emit radiation. So 80% of the material in the universe is invisible because it does not emit radiation. It may be that this hidden mass exerts such sufficient gravitational force to lead the universe to collapse. It believes that the gravitational force between the mass not only determines the motion and evolution of the planet, stars and galaxies, but also control the ultimate fate of the universe. The gravitational force between the masses not only determines the motion and evolution of the planets, stars and galaxies, but also control the ultimate fate of the universe. So some of the exam style questions that is available on page 294. Explain what is meant by the red shift of starlight. When the star starts to run out of hydrogen as a fuel for nuclear fusion reaction, it becomes unstable. So the amount of fuel for the to energize or keep the star energized is lost. So the nuclear reaction stops, it becomes unstable. There is a less energy being produced by nuclear fusion and to sustain the outward thermal pressure. So outward thermal pressure reduces, produced by the nuclear fusion to sustain the outward thermal pressure, and the core collapses inward, and as a result, if this energy is not produced, that core collapses inward under gravitational attraction, and the gravitational potential energy is transferred into kinetic energy so that the core becomes hotter. So this happens when a red shift of starlights. There is a fast burn up of the remaining hydrogen envelope in contrast to the core, and a huge expansion and a subsequent cooling of the surface gases. The star turns into a red giant or a red supergiant if the star is very massive. If there is a fast burn up of remaining hydrogen envelope in the contrast to the core, and a huge expansion and subsequent cooling of the surface gases, because this happens if there is a shortage of fuel, that is hydrogen, in the star, then it becomes unstable. Explain what the red shift of the starlight tells us about the motion of the distant galaxy. So this is a stable star where the input energy is equivalent to the outward energy. So when there is a short of fuel, then it becomes a red giant, and from that red giant, a low mass star and a high mass stars. There is a possibility of producing this supernova and planetary nebula with a white dwarf at center. So this is the red shift or the life cycle of the stars. State which of the following provide evidence in support of Big Bang theory. The red shift of starlight from distant galaxies. This red shift of a starlight from distant galaxies. Describe how a stable star is formed and how it is powered. Stable star, when interstellar clouds of dust and gas containing hydrogen collapses under the force of gravitational attraction, a protostar is formed. Interstellar clouds of dust and gases containing hydrogen collapse under the force of gravitational attraction, a protostar is formed. As the mass of the protostar increases, its core temperature rises, gravitational potential energy is transformed into a kinetic energy as the protostar contract under internal gravitational forces. When the core is hot enough, nuclear fusion can start. Hydrogen is converted into helium and a star is born. This is the origin of the star. Clouds and dust containing hydrogen collapses under gravitational attraction and a protostar forms. And protostars, the temperature rises, and when the core is hot enough, nuclear fusion starts. Hydrogen converted into helium and a star is born. Energy source is producing here. If the young star has a very large mass, it forms a blue or a white star. And if it has a smaller mass, such as our sun, it forms a yellow or a red dwarf. And this is more common. Explain when a stable star turns into a red giant. When a stable star turns into a red giant, when a stable star starts to run out of hydrogen. So the fuel of this star is going short or running out as a fuel for nuclear reaction. It becomes unstable. There is a less energy being produced by the nuclear fusion to sustain the outward thermal pressure. Outward thermal pressure cannot be sustained due to the less energy produced by the nuclear fusion. and the core collapses inward under gravitational attraction. Under gravitational attraction, the core collapses. It collapses inward. The gravitational potential energy is transferred to kinetic energy so that the core becomes hotter. There is a fast burn up of the remaining hydrogen envelope and a huge expansion and a subsequent cooling of the surface gases. The star turns into a red giant or a supergiant if the star is very massive. State the forces and their direction, which are balanced when a star is in a stable state. In a stable star such as our sun, the very strong force of gravity pulling it inward and balanced by the opposing the force trying to make it expand due to its extremely high temperature. The extremely high thermal pressure is expanding outward, and this gravitational potential energy is pulling inward. So these are balanced. So the stable star's life cycle is this. This thermal pressure arises from the kinetic energy of the nuclei in the core. State the sequence of stages in the life cycle of a star like sun. When the forces are balanced, the star is in a stable state which may last up to 10 million years or 10 billion years, during which time most of the hydrogen in the core is converted into helium. When the star starts to run out of hydrogen as a fuel for nuclear reaction, it becomes unstable. As the core heats up, the temperature becomes high enough for the nuclear fusion of reaction into a carbon to occur. This will happen to our sun, which is halfway through its stable phase, is in about 500 million years time from now. The inner planet Mercury will then be engulfed and life on Earth destroyed. This is the supposition that the estimated this sun has spent or is at its mid levels, half-life has completed almost with respect to this theory. So that's all from this star and universe.